In this video, we're going to show you how the CA code and the navigation message combined is modulated onto the carrier signal. Now that carrier signal is going to go to the L1 channel. That L1 channel carries a carrier wave of 1575.42 megahertz, which is basically 154 times the basic frequency on the satellite. So the carrier signal has what we call a sine wave, if you want to call it that, and then we modulate onto that the combination of the nav data messages that is summed up to the CA code or the PRN code. We use the modulo 2 adder to do that, and in the previous video we showed you how that was done. So we then have this bit code signal, and then every time there's a shift from a 0 to a 1 or 1 to a 0, the carrier signal sees a 180 degrees phase shift. Now, the way that works is, let's say here we go from a 0 to a 1. Normally we would have the sine wave continue like this on the carrier signal, but when it sees that change in the bit code of the CA code, the PRN code, we then have a sudden shift of 180 degrees on the carrier signal. So instead of coming back up, it shifts 180 degrees and goes back down. Here, you can see how the signal wants to go down and back up here, but then we have a 180 degree phase shift and it goes straight back up. These phase shifts can be captured by the receiver, and it's by noticing those phase shifts that we then realize we have a bit shift in the CA code as it comes down from the satellite. Now notice that the picture doesn't quite do justice. We see that there should be way more waves in the carrier signal for each bit message going across, and that is indeed the case. Notice that at this particular frequency, we have 1,540 waves of the carrier signal for each chip of the CA code that is transmitted. So we see a whole slew of these waves, and then every 1,540 waves, there could be a situation where we go from a 0 to a 1 or a 1 to a 0. Now, of course, the bit code doesn't just go 0, 1, 0, 1, and so forth. Sometimes it stays at 1, 1, 1 for a while, goes to 0 for a while, but each time there's a shift that causes a phase shift in the carrier signal, and that's how we then transmit that carrier signal with all these phase shifts on the carrier signal, and then the receiver then translates it back into the bit code and then understands what's inside the message. So that's how the message is transported from the satellite to the receiver. Pretty ingenious method, and that's how it's done. And that's what we call the BPSK, the binary phase shift keying method of modulating the carrier signal with the navigation message and with the PRN code.